Hello, and welcome to the first video of Programming with Patrick. My name is Patrick, and the purpose of these videos, at least as this channel starts, is to walk through some programming challenges and try to provide insight on how, at least I approach problem solving when it comes to programming. And hopefully that will allow you, the viewers, to think about, or not think about it, as well as experience what it's like to walk through these problems. So that's the style that I'm going to try to go for. And I mean, as time goes on, we'll see how it goes. To start out with, I have this first challenge from LeetCode. And for those who aren't aware, LeetCode is a platform that provides programming challenges. And when you are looking to interview with, say, Facebook, Apple, Google, the big tech companies, you might see them referred to as FANG. They'll ask some challenges in the interviews that are heavy, like in terms of algorithm and data structures. So the site provides a way to practice those problems. So I figured this is a good way to, some of these problems aren't exactly the most realistic, but it does at least provide an opportunity to perform some problem solving. We're going to start out with the first one, and I plan on just going step by step through each one until bored of it or just done. So hopefully you enjoy this. So without further ado, so here we have the first problem from LeetCode, which is titled toSum. So given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So with this problem, I'm also going to try to, especially when it comes to the easy problems, I'm going to try to take a little bit more time to explain programming concepts along the way, just to help with maybe you've been exposed to, say, integers and you just can't quite remember what those are, or you've heard of indices but you can't remember what they relate to. I'm going to try to focus on explaining those topics as well as working through the problem. So hopefully this will be a benefit to anybody who is watching. So starting out, we have, I'm going to program primarily in Python 3. This website, LeetCode, allows you to program in a bunch of different languages. So if you're, say, a college student, you might be using C++, or maybe you're using Java. I'm going to use Python 3 because, at least when it comes to syntax, it's relatively light, and I feel like it's easier to read, so there's less to get caught up in. Okay, so as you can see, when I switched to the language, the LeetCode automatically gave us some code. So to start out with, it gives us this solution class. So if you are, again, just starting with programming, a class is typically seen as some type of object, or you can think of it as like a special kind of container that could be reused. But it looks like we're only going to be using this once in order for it to behave properly, for this LeetCode to behave properly. So inside of this class, or this container of solution, we have this function, which is denoted by this def. So we have this function called toSum, and by default it takes in a couple of arguments. So we have a list of integers, and integers are just whole numbers, so anything from, you know, negative infinity to -1, 0, +1, all the way up to positive infinity. So we have this integer, and we have a list of integers. So those are all of our numbers. And then we have a target, and that is also an integer. And what we want to return is the two indices, or integers, that when you access them in the list, they return, and add them together, they return the target. So let's walk through the example. So given a list of numbers, so we have 2, 7, 11, and 15, we want to target 9. And so if we look at this and we say, okay, we have 2. Now, what could we add? Can we add 2 to each of these terms after it in order to get 9? So 2 plus 7 is 9, and that's it. Because they have specified there's only exactly one solution, we, working through this problem by hand could actually be done. But let's just keep going. Say that we wanted a different target of, let's say we want the target of 26. So we add 2 to 7, and that would give us 9, so that's not it. Then we add 2 to 11, 13, that's not it. 2 to 15, that's 17, still not it. Again, we're looking for 26. So then we exhausted everything added with 2. So let's move on to the next term. So we have 7, we added to 11, that's 18, not good enough. 7 added to 15, that is 22, still not good enough. So then finally we have 11 and 15, and that gives us 26. So this is what I just did, was I walked through how we can at least identify how to figure out what is the sum. But what we need to keep track of is the index in this list. So because this is Python, and most programming languages, they start with an index of 0. So in this list, the first entry is of index 0. The second entry is of index 1. So if we try to reference this in Python, we could also use square brackets. So we have our list, and we want to access, using the square brackets, an element of this list at a certain index, so 0. And we're going to do the same thing here, plus inside this list, access the element at index 1, which gives us 2 plus 7 is 9. And so therefore we want to return 0 and 1. Those are the two indexes that give us the final result. So let's go ahead and get started with this. So we have our function defined toSum, and what I'll do is I'll start with that more brute force approach of just we'll iterate through each element inside this list. So first, I'm going to say I'm going to create a variable called first element, or I'll call this the first term index, and then second term index. So when we start out with, because we have the rule that we can't use the same element twice, by default, the minimum number that these indices could be are 0 and 1. So now what we can do is start iterating through everything. So we can say for, and as I write stuff out, I'll probably make some changes, do some code cleaning up and stuff like that. So for, we're going to iterate through this whole list. So like in the case when target was 26, we started with 2 for the first term, then we moved on to 7, then we moved on to 11, but we never hit 15. So we want to start at 0 and end before the end of that list, the last term in the list. So in Python, okay, that's just a test case. In Python, there's a function called range, which will allow you to create basically a list of numbers. And you can specify where to start. So I'm going to start at 0 and where to end. So in the case of, say, the target was 26, we want to start at 0, and then we want to end at 0, 1, 2. We don't want to go all the way to 3. So we can get the length of our list by using the function len for length, and then numbers. But the length of this list is 4, and we want to stop at 0, 1, 2. So we want to subtract 2 from that. So what this is going to do is generate a list of numbers that looks something like this. Next, we want to do a similar thing because we want to keep checking for our second term. We want to start at, basically we want to start at 1 plus the first term, and then go all the way until we hit the end of the list. So for our second term index, we're going to have a range where we start at the first term index plus 1, and we're going to end at the length of the numbers minus 1. And the reason for that is this length is 4, but because we have an index starting at 0, we have 0, 1, 2, and then 3. So this would give us our 3. So just to reiterate here, this will give us something like 1, 2, 3 in the case of the first loop. Okay, so now we have our first term index and our second term index. So what we can do is we can say if our Here, first let's just access the terms. So our first term is going to equal the number at the first term index, and then the second term is going to equal the second term index. And what we'll do is we'll say if the first term plus second term, and I'm just going to wrap it in parentheses just to make it more obvious. If that equals our target, then we are going to go ahead and return the first term index and the second term index. Okay. And this should be it. So let's walk through the example of the given example. So in the given example, the target is 9. So first, we set our term index, first term index to 0, second term index to 1. And then what this loop does is creates this list here, and we set this first value to the first term index. So at this point in time, first term index is equal to 0. And then in this loop, we have first term index equal to 1. So therefore, first term is going to equal 2 because its index is 0, so it's going to grab this one, this 2. And then second term is going to equal 7 because the second term index is equal to 1, which is the second element in the list. 2 plus 7 does indeed equal 9, so therefore we're going to enter this if statement and return our array here. So I think if I just run this, I'm not sure if it's going to test everything or just test this one. Yeah, okay. So we have this test, we just ran this code and it does work as expected. So what if we run, I don't know if I can change it. So let's say if we want to get to 26. So again, starting out, first term index 0, second term index 1, first term index, you have, we start out with 0, second term starts out with 1, so first term is going to be 2, second term is 7, 2 plus 7 does not equal 26. So therefore, we go back up to this for loop, and we go to the second element in that list. So now we have 2 plus 11 does not meet. So then we go to 3. The 3 index, which is the last element in the nums list. So we have 2 plus 15. Well, that's 17. It does not equal 26. So at this point, we have iterated through everything in this list. So therefore, we need to go back up to this for loop, and we move on to the second element in that list. So now our first term index is going to equal 1. Since our first term index equals to 1, what happens is this second for loop is actually going to reduce in size because it's the first term index plus 1, so 1 plus 1 is 2, and we go to the last element in the list, which its index is 3. And just going through, So index element at index 1 is 7 plus element at index 2, 11, 18, not good. And then changing to 3, 7 plus 15 is 22, not good enough. So we move on to, for the first term index, move to element of index 2, which reduces our list down here to only this final term. And so we have 11 plus 15 does equal 26. So therefore, our code would return 2 and 3. So if I change this to 26 and I run this, it might give an error just because, yeah. Let's see. Probably made an error somewhere. Let's see what happens when I submit this. Okay. So there's a situation where it's not outputting when it should. So something that we can do for debugging is we can print out just some information to see what's happening. So let's go ahead, and when we tested this with 26, you can see 2 to 7, 2 to 11, but notice that it doesn't go to 15. And that's because I forgot that with Python, it is the range function is exclusive for the last element, or for the last number. So you actually so if you give a length of 4 and say you started with 0, you go all the way, it would count 0, 1, 2, 3, and just won't go to 4. So that was my bad. Again, when you flip between languages and stuff like that, it can be pretty easy to forget that kind of stuff. So, okay, we were able to get the expected output, so that's okay. So I'm going to go ahead and remove this debug statement, run the code again, make sure 26 still works, yep, and submit this. Okay, so in this situation, the time limit exceeded. So they supplied a very large list of numbers, and the sum was a pretty large number as well. So it just took too long for the code to execute. So let's go ahead and start simplifying this code, and then think about how to approach this in a different manner. So the first thing I want to do is, with these loops, the first term index and second term index, using this for variable in list syntax, it gets assigned a value every time. So therefore, oops, these first two variables aren't necessary. Okay. What else can we clean up? Another thing that we could do in order to kind of simplify this some is actually, this is probably okay for now. Actually, we can simplify this a little bit more. So in Python, it's not going to speed it up, so I'm actually going to hold off. So how can we make this go faster? Before hopping to the solutions, because I did see that there are multiple ways to approach it, but I didn't read them in detail because I did want to try to think about it myself some. So if we look at least the hints. So the first hint says just do what we exactly did, which is search for all possible pairs, but that would get slow, and we don't want to do that. So let's look at the second hint. So if we fix one of the numbers, say x, we have to scan the entire array to find the next number, which is the target minus x, where value is the input parameter. Can we change our array somehow so that this search becomes faster? Well, something that isn't exactly given is that whether or not our array of integers is sorted. So if it is indeed sorted, and based on this hint of we start with x and we're trying to find y based on the target minus x, well, we could start looking from the back of the array or the list. So that's a possibility. And maybe something that would be better, just thinking about it some more, is that so instead of going element by element, maybe what we can do is first let me see what this last hint says. The second train of thought is, without changing the array, can we use additional space somehow, like maybe a hash map to speed up the search? And this is what I'm thinking about. So if you aren't aware, a hash map is a way of, in simple ways, it's very similar to almost like a locker inside of a school, where you as a person are likely, in high school or elementary school or whatever, you're assigned a locker. So you have this unique place that you can go to and put your information into. Typically it's books, but in terms of programming, it's a way to have a special key. So you feed it some information, and what it does is, such as a string, what have you, and it will perform a computational hash on it in order to produce a unique key, hopefully unique. And with that unique key, it can quickly point to, oh, the data associated with that key is over there in that locker. in that theoretical locker. So we're going to go ahead and look at that. So how do we do this? So what we want to do is I'm going to take this function, copy and paste it. So I'm going to copy and paste it, and I'm going to rename this one to slow. So this is a slow method that we've had, but let's come up with a faster one. So we want to iterate through the indexes. So I'm going to finish writing this line and then talk through it some more. Okay. So what we can do is say we have 2. Okay, we start with 2. And say our target is, I guess start with 9. And then we'll do 26. So if our target is 9, we can start with 2. And we can say, okay, what are we looking for? If we have 2, we're looking for 7. And if we find 7, we want to be able to reference where 2 was found originally. So therefore, we want to imagine that we want to store the index of 2 inside of 7's locker. That way, if we find 7, then 7 will know where 2's at, and because we're on the term 7, we know where 7's at, so now we have reference to both where 2 and 7 are. And we would stop there. Now in the case of 26, so we have 2, we start with 2. 26 minus 2 is 24. So therefore in 24's locker, we are going to store the index of 2, which is in this case 0. But notice that we don't have 24 in this list. So, I mean, we can easily see in this example that we will never open 24's locker. But if you have a super long list, it will be hard to tell that. So that's okay, but we're just going to store it for later, and if we find 24, great. If not, we're going to find something because the problem says that there is exactly one solution. So we move on to the next term. And we say, okay, this is 7, so 26 minus 7 is 19. So in 19's locker, we're going to store 7's index, which is 1. Now we move on to the next one, 11. So 26 minus 11 is 15. So in 15's locker, we're going to store index of 11. And I should also mention, I forgot, that before we start with 2 and storing 2 inside of 24's locker, we check to see, does 2 already have something inside of its locker? If it does, well, we're done. If not, then we go elsewhere, store the index in the locker, and move on. And we repeat this until 15. 15, we check, is anything inside the locker? It is. We have the index of 11, and so therefore we can return our result. So let's do that. So the first thing is, let's check if anything is in this locker, else store in like the complementary locker. Complementary locker. Okay. So if what I'm going to have to do is create this hash map or this locker system, and for that I will call this I'm so bad with names, so let's refer to this as number hash. I don't know. And what this is, it's a dictionary. And we're saying that if what I'm going to do is I'll try, and I'm going to try to get I want to access the current numbers locker. So for this number hash, I'm going to access the current numbers. Locker. And if I can do that, whatever's inside of this locker is the complementary index, and therefore what we can do is return index and the complementary index. But what might happen, and what's likely going to happen, is that when we go to access this, so like in the case of 2, for 2 is not inside of this dictionary yet, and so therefore it's just going to crash. And what it's going to do is throw an exception, and it's going to give a key error in Python. This could be done many different ways. You can use an if statement, but I think this reads relatively well. So we're going to try to access some data and return it. But if we receive this exception or this error is not like bad. It's not going to. So we're catching it using this except statement, and we're going to say, okay, well, we couldn't find it, so let's take this current numbers and subtract it from the target, and this is going to be the complementary term. And what we're going to do is say, okay, for that number hash, for that complementary term, we want to store the current numbers index. And that's it. And then we're going to keep on iterating through our list, just like I walked through earlier, to see how that works. So let's go ahead and run this and see if it still works. So it does indeed work. The numbers are swapped, but that's okay. They didn't say exactly what order they needed to be in. It's just they need to return the 2 indices. So, so this should be faster, and we're going to submit this and see if it runs better. And it was accepted. So why is this faster? let's walk through that example. So in the previous code, what we had to do is we start with like one term, and we have to iterate through each one. We go to the next one and iterate through each one, and then so on and so forth. So as you're learning about programming, you have this notion of big O, which is the complexity, at least focusing on time complexity. And the time complexity of this second loop is of n squared. And the reason for that is for this first loop, we are iterating through n minus 1 elements. And then for the second loop, we're iterating through, it's a smaller set. It's going to be n minus, what is it? So in this case, we have 3, and then 2. I mean, in the worst case, you have n minus 2 for each loop. And so therefore, if you because this is a nested loop, this n minus 2 is inside of n minus 1, you would just multiply them together, and you get n squared, so on and so forth. And because n squared is the dominant term, it's just n squared. That's the complexity of it. So as your list gets longer by 1, it's growing at a quadratic rate. Whereas with this top solution, using the hash, the advantage is the time complexity is only of n. So here you can see that we're iterating through only the list of numbers once, at most. That's it. So therefore, the complexity of this is just n. The downside for this top algorithm is that we have to use this memory device. And the memory device here is going to be of size n. Whereas down here, the time complexity is n squared, but there is no memory other than like the provided list of integers. So therefore, there's no additional storage necessary. So before I wrap up, I want to take a minute to clean this code some. And so I'm going to go ahead and move this comment. And what we can do to simplify this code some is inside of Python, there's this helpful function called enumerate. And what it does is it returns both the index and the current number, or like the element, the item. So in this case, for this first loop, you would have 4, and then the index would equal 0, and the current number would equal 2. And what this does is allows us to simplify this code so we don't have to keep using num's index. We can just use current number. And hopefully that makes it a little bit more readable. And with that, I think that should do it. So let's go ahead and submit this one more time. Make sure that this answer is still okay. Yep, it ran. Okay, so that's going to conclude this first video. I hope you enjoyed it. Please leave any comments about if there's anything that you would like to see in particular. I will continue to try to walk through problems based on feedback. I might change the style of this, but I do want to try to just provide a very in-depth explanation about how this works. I know that at least walking through this, I wasn't exactly explaining everything, especially with like for loops. But hopefully these examples will help to solidify the ideas. If there's a need for further explanations about for loops and stuff like that, I might create like other content related to that. But at least just to get started, hopefully these more practical examples can help out. So thank you for your time, and see you next time.